Welcome to Twinkling Minds. In this video, we are going to learn how to find LCM of given set of numbers. This is part 1 of the video where we are going to learn basics. What is LCM, prime factorization method and division methods. Let us dive into the basics. What is LCM? LCM is least common multiple. What is that? It is the lowest number that can be divisible by all the given numbers. So the least common multiple or LCM is greater than or equal to the highest or biggest number in the given group of numbers. Simple, right? So it is the lowest number that can be divisible by all the given numbers. Let us take a simple example with two small numbers 4 and 6 to understand what is LCM. So for that we need to understand the concept of multiples. So you should know the tables. That's why I have taken 4 and 6 so that we can easily understand. Okay, what are the multiples of 4? 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, and so on, so on, so on. Now let us look at multiples of 6. What are those? We know 6 table, right? 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24, and so on. Now, what are the common multiples? The first common multiple in both these is 12, right? Then next one is 16, no, 20, no, 24, yes, we have 24 as a common multiple, second common multiple. And let us look at next 28, no, 32, no, 36. Yes, next common multiple is 36. So the like this it goes on. Let us stop here. So what are common multiples are 12, 24, 36 and so on, right? But what we need to find is least common multiple. So the smallest in this set is 12. So our LCM for 4 and 6 is 12. Very simple, right? Isn't it? But if the numbers are big, what can we do? Or we need to find out LCM for more than two numbers, 5 numbers, 6 numbers. We need to do it in a different way, which we are going to discuss now. Now we will learn how to find LCM using two different methods. The first one is prime factorization method. The second one is division method. Now let us start with small numbers so that we can easily understand how can we find LCM of given numbers using prime factorization method. Basically, prime factorization method means take each number and try to find out prime factors for that particular number, starting with the smallest prime number. The smallest possible prime number. So let us get started. The first number is 4. Let me draw this. What is the smallest prime number that can divide 4 with remainder as 0? That is what is called as a factor, right? When we divide a number with another number, the remainder should be 0, so that the second number will be a factor of the first number. Here for 4, the smallest prime number that can be a factor is 2, right? So divide this 2. And what is the quotient? We are going to write quotient below. The quotient is 2. 2 2s are 4. We will continue this till we get quotient as 1. So now we need to divide this 2 with the smallest prime number that can divide this, that is 2. Okay. Quotient is 1. So we got it. So the prime factors for number 4 are 2 and 2. Now let us do the same for 6. Find the prime factors for number 6. So the smallest prime number that can divide 6 is 2. How many times? 3 times. So the quotient is 3. Now again we need to divide this to get quotient 1. So the next possible smallest prime number that can divide 3 is 3 itself. So divide 3 with 3 and quotient is 1. So the prime factors for number 6 are 2 and 3. Let us do it for 8 as well. Okay. 8, smallest prime number that can divide 8 with remainder 0 is 2. So 4 2s are 8. So our quotient will be 4. Again, the smallest prime number is 2. So divide, the quotient will be 2. Again divide with 2. Quotient is 1. So the prime factors for number 8 are 2 multiplied by 2 multiplied by 2. Now let us find the LCM of these three numbers. So 4, what are the factors? We got prime factors 2 multiplied by 2. For 6, what we have got 2 mul 2 multiplied by 3. For 8, what we have got 2 multiplied by 2 multiplied by 2. Now let us find the common factors for these three numbers. So what we are going to do here is we will try to find out common factors first and consider only one for each common factor. So what I mean to say is, let us look at this. 4 is having 2 as a factor, right? Similarly, 6 is also having a 2 as a factor, and 8 is also having a 2, which is a factor. So we will not consider 3 2's here for finding LCM. We will only consider 1 2 for this group. So our LCM for our for our LCM we will only consider 1 2 as a factor. Then let us move to the next two. Generally we start this with the number which is having less number of factors. So 4 is having only two factors, so that's why we have started with two factors. We can start with 6 as well because it is also having only two factors. So but 4 is the smallest number, so I have started with 4. Now this is done. So let us take the next factor for 4. That is also 2 here. Do we have 2 in 6? No. And do we have another 2 as a factor in 8? Yes. Right? So we will consider only 1 2 here for LCM calculation. Right? Then let us look at the next factor. So we are done with 4. Now 6 we have a 3. Okay, now this 3, do we have any 3 in either 8 factors or in factors of 4? No. So we'll consider this 3 right away. Now, do we have any other factor left in 6? No. So in 8, we have one more factor, 2. Do we have any other factor which we can group under 4 or 6? No. So this is an orphan again, like 3. So take it and multiply. So our LCM is nothing but product of these four numbers. So what is the product of these four numbers? 24. So our LCM is 24. This is how we calculate LCM using prime factorization method. First step, find prime factors for each of these numbers. Then find out common factors, at least two. It can be, if you have two numbers, you need will be two. If you have three numbers, it can be two or three. If it is four, it can be anything more than two. For every common factor, you consider only one factor, only once. So here we have these three. For these three, we consider only one, two. Similarly, here we have only, out of three, we have only twice. So we consider only once. And the orphan factors 3 and 2, we have considered, and your LCM will be nothing but product of these factors. That's it. Now let us look at division method. For the same set of numbers 4, 6 and 8, how can we find LCM using division method? Okay, first step, keep these numbers side by side, separated by commas, 4, comma, 6, comma, 8. Okay, now we need to consider the smallest number which can divide at least one number. It can divide more than one or all the numbers, that is perfectly all right. But that number should be a factor of at least one number. We will continue this till we get all the quotients as 1. So the smallest number that can divide these numbers is 2, right? So let us get started with 2. So what is the quotient for 4? We are going to write quotient here. So what is the quotient for 4 here? 2, comma. For 6, what is the quotient if we divide 6 with 2? 3, comma. And if we divide 8 with 2, what is the quotient? 4, right? 4. Whether these quotients are ones? No. Then we need to continue this iteration. Which number? We have different numbers here, 2, 3, 4. Okay, let us take the next smallest number that can divide at least 1 in this group. So 2 again. So 2. So first number 2. If you divide 2 with 2, quotient is 1, comma. Then whether 3 is divided by 2? No, right? So we will just directly take this number below 3. Then again 4, how much? 2, right? Quotient 2. Right. We need to repeat. Now we have 1, 3, 2. No need to consider this 1, not required. Either 3 or 2. As I mentioned earlier, the number what you are going to consider must divide at least one number. So let us take 3 now. 3. So 1 will just take it same because as discussed earlier, if you can't divide, then we will just take that number as is. 1 anyway, quotient is 1, nothing to do with that anymore. Now 3 threes are 1, so the quotient is 1 here. Again, below, can we divide 2 with 3? No, then we bring it down 2. We need to repeat this again till all becomes 1. So the next, what number we need to consider? This is already 1, this is already 1, this is already 1, so 2. So we need to divide with the 2 quotients 1, 1, 1. Now your LCM is nothing but product of these. So 2 multiplied by 2 multiplied by 3 multiplied by 2 again. So 2 twos are 4, 4 threes are 12, 12 twos are 24. So our LCM is 24, isn't it? So simple. So by using these two methods, we can find LCM of any given set of numbers easily. Sometimes you may have big numbers, so we may have to do it more number of times, more iterations, but this is the approach or the method which we normally follow to find LCM unless specifically asked to find in prime factorization method. Why? Because prime factorization method takes longer time compared to division method. So if it is not explicitly mentioned, find LCM using division method. That's all in this video. Thanks for watching. Please do not forget to watch part 2, which I am going to upload very soon, where I am going to discuss about various tips and tricks. Please do not forget to subscribe. Bye bye.